Welcome to DSEJ home classes. Namaskar. My dear students, hope you are all fine and doing well at your places and you are doing well in the studies also. My dear students, today I am going to start with the next topic of the chapter Morphology of the Flowering Plants, and the name of the topic that we are going to discuss today is the stem. My dear students, let's talk about the definition and the main functions of the stem first. The stem is one of the two main structural axes of the vascular plants, the other being the root. What I mean to say by this is that the stem and the root. These are the two main structural components of a plant which are indispensable components and without which there can be no identity of the plant and no existence of the plant. The first is the root that we have discussed last time. Today I am going to discuss the next structural axis, and that is the stem. The stem acts as a bridge between the root and the rest of the parts of the plant. The stem acts as a bridge, that is, this is the stem and this is the root, and these are the various structural components, leaves, flowers, fruits, etc. of the plant, and the connection between the root and the rest of the organs is maintained by what we call the stem. Of course, the stem is very crucial and important component. It supports leaves, flowers, fruits. It transports fluids and produces new living tissue for increasing the height of the plant. Now, it can transport the fluids from the root, that is the water and the minerals which the plant absorbs from the root portion are transferred to the different parts via stem. Moreover, the food which is manufactured in the leaves of the plants by the process of photosynthesis is transported to various parts via stem through the phloem, and the water and the minerals are transported through the xylem. Now, my dear students, as we know that the stem is very important organ of the plant, and it is identified by the presence of nodes and internodes, which is important structure of the nodes. Moreover, the stem is also modified in certain ways in order to perform some special functions. Let us have a look at the various functions that the stem performs. The main functions that is performed by stem are, that is, the stem holds the leaves in a favorable position to receive the light for the photosynthesis. What I mean to say by this, that the leaves in the plant, they are held in favorable position, that is, they are present at such a place that they get the maximum sunlight, and this is made possible by the increasing length of the stem. In the same way, the flowers are also held in the favorable position for the pollination, that is, the flowers are clustered together in their respective inflorescences and they are placed in such a way that they are positioned on the stem in such a way that the pollinators, they have an easy access to the flowers. Another function which the stem can perform is the photosynthesis. How? Most of the stems, they contain chlorophyll and they manufacture food by the process of photosynthesis, and in this way they bring about the photosynthesis also. Now, they can store the food as well as the water. They transport water and mineral salts from roots to the leaves. They transport food from the leaves to roots. That is, the food is transferred from leaves to the different parts of the plant, and the water and the minerals are transferred from the roots to the different parts of the plant, and this function is performed by the stem. As we discussed the modifications of the root, similarly, stems are also modified for certain purposes. let us have a look at various modifications of the stem. The stem modifications, there are the underground modifications of the stem, there are subaerial modifications of the stem, and there are the aerial modifications of the stem. The underground modification, they include bulb, corm, rhizome, and the tuber. Similarly, the subaerial modifications of the stem, they include runner, stolon, sucker, and the offset. We will be discussing these one by one. Then the aerial modifications, which include various kinds of creepers, trailers, and climbers. And there are two more modifications that we will be discussing. One is the phylloclad and the other is the cladode. And these are in addition to the above modification, and these modifications are seen in the xerophytic plants to make the survival of the plant possible in the desert conditions. Now let us first of all discuss some different modifications of underground stem, and as I told you, these are rhizome, corm, bulb, and the tuber. Example of the rhizome is the ginger. You can see these lines on the ginger, which represents the node, and between the node is the stem segments, are to which we call the internodes. Similarly, we have the corm. The example is the colocasia, where we have these light and dark brown lines representing the nodes and internodes, and these modifications of the stem are for the purpose of storage of the food, and these are underground, and the leaves are present above the ground. Similarly, we have another modification which is called as the bulb, and the example is the onion, Allium cepa, where the adventitious roots are present underground, and then the leaves are present above the ground, and a deliquescent stem is present in between the leaves and the roots. Now we have potato, the modification called as the tuber. You have seen some depression like structures on the potato. Potato bears these depression like structures, to which we call eyes of the potato, and actually these are the nodal portions of the potato. Any portion cut with a node, this eye in between, can develop into a new plant, and therefore it also helps in the process of perennation or the vegetative propagation, also storing the food. Now next is the subaerial modifications of the stem, that is the stems which are present above the ground but very close to the ground. How is it so? In this type of modification, the stem trails on the soil or is found partially beneath the soil in such a way that it remains in contact with both soil and air. Stem is modified for the purpose of vegetative propagation and the perennation. That is, this subaerial modifications offers a very unique phenomena for the vegetative propagation, which is of extreme importance for the various horticultural practices. And some examples of the subaerial modifications are runner, stolon, offset, and sucker. How they look like? These are the examples. The runner, this is nodal portion, this is internodal portion. The nodal portion wears the root on the under the ground, and the nodal portion, it creeps over the ground portion. This is the runner. Example is the cynodon dictylon, the garden grass. Then we have the stolon. A little, it is almost the same with a little difference, that the internodal portion is slightly raised from the ground level, rest it is like the runner. One internode long stolon is called as the offset, again bearing the nodes, roots at the nodal portion and creeping on the internodal portion. And then is the sucker, where the roots are born at the nodal portion, then the stem elongates, bears leaves on the upper side and roots on the lower side, and then the internodal portion elongates. This example is the sucker. These are the some of the subaerial modifications of the stem. Now we have the aerial modifications of the stem, which are represented by various modification, as I told you, phylloclads, cladodes, thorns and the tendrils. Thorns, tendrils, creepers, these are the aerial modifications of the stem for making the survival of the plant possible, whereas phyllodes and cladodes are the xerophytic adaptations. What is the difference between phylloclad and cladode? Let's have a look at it and what are the similarities in them. Phylloclad, both main stem and the branches are modified to function like leaves, whereas only branches are modified and take over the function of the leaves. Actually, what is the case that in the xerophytic plant, mostly because of scarcity of water, the leaves are very much reduced. Either they are caducous or spine-like or scale-like leaves, as a result of which the transpiration is reduced because of the reduction in the size of the leaves. Now, in order to carry out the photosynthesis and the storage of water, these modifications, they come into existence, which are the phylloclads and the cladodes. Both phylloclads and cladodes, they have unlimited or indefinite growth. That is a similarity in them. The phylloclad consists of several nodes and internodes, whereas the cladode, it is only one internode length, because only branches are modified for forming the cladode. True leaves are commonly caducous in case of phylloclad, or they are reduced to scale or modified to spine in case of cladode. Example is the Ruscus aculeatus asparagus in case of phylloclads, and the examples of the cladode are the Apuntia, etc., Euphorbia, Rollinia, etc. These are the differences and the similarities between phylloclad and cladode, and these both are succulent, green in color, perform photosynthesis and reduce the loss of water through transpiration by adaptation, so called the reduction of the leaves into caducous spines or the scale likes. So this is a unique adaptation to the xerophytic conditions. Then we have discussed the other aerial modifications, which could be creepers, climbers, etc., tendrils, etc., and what are the difference. With small differences, these show the adaptations. The plants that take the support of the neighboring structures and climb up are called as the climbers. We have seen many plants which climb with the support, whatever is the adjoining support, they show the thigmotropism, that is sensitivity to the touch, and they rise that support and reaches to the height where they can get maximum sunlight and cause the photosynthesis. So in order to enable the plant, despite its weak stem and climbing with this support, these plants offer a unique adaptation and by modifying the stem a little. Similarly, the creepers do not rise with a support, but these are the weak stems and they cannot stand upright and they spread on the grounds called as the creepers. Similarly, we have tendrils, and these are all the modifications present in the weak stems otherwise, but they rise to the heights or they spread on the ground and thus bring about the vital functions of the plant. So the modifications of the stem are in such a way that they enable the plant to withstand the environmental conditions wherever it is existing. So these are some of the modifications. I hope you have understood the topic, and I would like it that you all, my dear students, you go through these modifications one by one. And till then, that's all for the topic today. Thank you. Stay safe, stay healthy till we meet next time with the new topic. Till then, God bless you.